Now to complete analysis, and you see there are a lot of error because cracking. Okay, crack. This analysis crack not include rebar, so you have to check it later. All about the cracking. Okay, just a warning. So now let's check for the displacement. Okay, displacement, you can check for the displacement. Okay, load displacement, and you can start animation. Press escape, and you can check for the force. Now click on column. Okay, we want to show on the ground floor only. And click on the filter, and come back to design, check for the bye and check here bye, and the moment in the beam is not included in the center of the column because we use a clipping option, so the moment take at the face of column, and the reinforcement also take from the face of column. You can check here. This one, the maximum value you can take value on diagram. You see here the maximum moment is 346. So after you got the moment, you can design rebar in concrete beam. Okay, this one at the top is 255. Okay, check for the edge. Edge is torsion. You see here, when you use the beam connect at the center, at the center span, at the inner span, it is not affected too much from the torsion, but at the end span, you see here, you see much torsion. So you must to include torsion in design for the H beam, and this and in this beam also include for the torsion design and check. Okay, so here the internal column, internal beam not this is not affect too much from the torsion, but at the edge of beam they are resist for the torsion. Okay, you see, just take a look, and you have to focus about this beam. Okay, and now I'll continue to set. Okay, you can check here in the column the maximum bending moment in column. And the maximum bending in this direction is too small if compare with the back axis, so the column you have to design or increase the section of the column. And if this section can pass, you can increase, and if when you increase 0.1 meter, but this section cannot see, and the owner require fit the section, so you have another solution to add ball and to add another ball and in this direction to reduce bending moment in the column. The another option for analysis and design. Now let's check for the beam. Okay, now let's check for the beam. Click on the beam and click on the reinforcement. Click on the AY, the longitudinal reinforcement. 3. AZ is the longitudinal reinforcement. You see here at the location at the bottom of beam need 18 square centimeter. Okay, 18 square centimeter. So it's a just take a look. 18 centimeter analysis. 18. It need 6 dB 20. If you use 20 diameter, 6 dB 20. Okay, at the bottom, and at the top you use 6 dB 5 dB. Okay, so 5 dB, so you can use 6 dB at the top and use 7 dB at the bottom. For secondary beam, need a small rebar, and this one also for the longitudinal rebar need a smaller than the internal span for the longitudinal rebar, but this one for the torsion rebar. See here, for the torsion rebar, the H beam it needs more rebar to receive for the torsion. Okay, this beam and this beam and this beam. So you see here, the total reinforcement received for the torsion is around 20. So you have to optimize and check about the side and the reagent to avoid the error. I think this torsion is around 15. Okay, so let's check. Okay, it's 5 dB. Okay, so you use the rebar in the area as same with the column. We distribute the rebar along the parameter of the length or the stirrup. Now we not use the same with the internal column. Internal column you at the bottom and the top, but in this sorry, at the internal beam you use at the top and at the bottom, but at the beam we use at the side, also in the sidebar with the top and the bottom bar. Okay, now let's check for the direction. Okay, AZ, AY, okay. In beam is not has a light effect, but in column you can check here in the column. In the column, you see here in the in the back axis, you see here you need more rebar. You need around 34 and around 31 in one phase. Okay, in the phase you need 34. Now let's check about 34. Uh, 34 you need one phase is you 20, you need 11 bar for one phase. Okay, one phase, and if phase you need 20 more 20, but so you need 40 dB in one column. In this case you have to increase the section of the column. Okay, you have to increase the section of the column. So if you cannot issue the moment applied on the column, you can add another wall to resist that lateral force from the wind load. So your column will be need less rebar than this criteria. Okay, now you see here the maximum. Okay, the maximum is the location, and in the location is the same. Okay, it's the same. So now let's check for the another rebar in the column. No, not effect design for the torsion. So let's come back with the displacement, resistance and force, and we want to go forward for design of column. Now let's check. Now I check for this column. Okay, this column. So now let's check the column, and you use this icon and click on it. You see here, the maximum rebar is 32 and 25, and the capacity is 105. So it says it's greater than require 5%. So in the case if you don't want to use much rebar, you can increase the column section. Okay, now let's start with the interaction curve. You see here interaction curve. The load control, the calculation is load combination 110. Okay, 110. You see here the 110 is 1.55 in load multiply line load multiply with load. You can check. Okay, you can check for interaction, and now check for the SH with umbri. You see here the interaction. In this interaction according to the diameter of rebar you input in this section. Okay, so now you can check for the AZ Okay, for the asset, the maximum is on the column. Okay, so click on the column, right click, open with design module. After you complete analysis and design, and you can come back to design the section or the beam and or the column, and you can come back to analysis and design it again. This is the process to analysis and design. After complete analysis and design, you can optimize it again. Optimize the section, optimize the rebar in the section, optimize the thickness. Okay, but in this stage we focus on how to design the section past the apply load. We not focus too much about optimization. You have to pass the first step to pass the design. After part of the design, you can modify it again and come back to optimize it. Okay, now let's show it. You see here about the geometry. Geometry is rectangular, and the upper and the backlink you it automatically from the advanced design, and design setting. Okay, column design, concrete we use certified megapascal concrete, and concrete cover is 3 cm. Now let's increase the section to 50 multiplied with 60, apply. Okay, and reinforcement. Now we fit for longitudinal reinforcement 20 and 25, and for the shear we use diameter 8 mm. Apply. Okay, a load combination. You see here all load combination. We have to add design. Okay, design combination. You can generate. Okay, for design. Okay, internal force. It is import automatically from Graitec Advanced Design. You see here the maximum gun is 372 times, and the moment is here. You can check at the top and at the bottom. Okay, the moment is here. You can check about the moment. Click OK, and you can calculate it again. You see here, provide reinforcement D are too small. Limit reinforcement class B can be div. Okay, calculation result. You can check about the result. Longitudinal at top is over. Okay, and longitudinal bottom is pass. So in the case you have to increase your section and or increase your concrete strength. Now come back to geometry and increase it to 60. Apply and OK, and run analyze and design again. Okay, now you see here the section. The reinforcement is productivity. We not focus about this. Okay, now pass the design. So you have to increase your section to 0.6 multiplied to 0.6 meter. Okay, now indicate you can click on this bar, double click on it, and take one. We use the pin. Okay, click on pin, click on pin. Okay, 2 we use pin. Okay, apply. Okay, complete. Now we got the analysis and design result for the column. We can click on this bar again, click on this bar, double click on it, and you see here the diameter is 25. The design ratio is 96. So you can increase it to 5 and 5. Apply. Okay, now the design ratio is around 72. Okay, is around 72 when you increase the section to 0.6 and 0.6. Okay, and the diameter of longitudinal reinforcement is 25. You can check for the interactive drawing. Okay, this for drawing, and for the concrete strength, steel shear strength, and formwork. This one for the bar list. You can check for the interaction curve. Okay, you see here the interaction curve. You can check for diagram. You can unload all load to take the maximum load, and the load combination I'm not taking envelope. So if you want to easy to check about the maximum load from all of this combination, you can include envelope. Okay, envelope auto load combination. You can check here for the axial load for the moment. Okay, now let's check and close. If you want to apply the change to the corresponding element, so if you want to change, you can close and update. This section will be automatically update in the Graitec design. Now I want to close and update. Okay, now we come back to the model in GAD. Okay, and let's see in design. And we will focus for this column. Okay, now this column we use the section 0.6 multiplied with 0.6 meter, and the concrete is frequency 35 megapascal. So in the case you can reduce concrete strength and to optimize the design section. Okay, or you can keep for the concrete strength. Now back again, we click on this column and right click, open design menu. Okay, now check on reinforcement. We use the same 25 and 20. We don't want to use another diameter, and apply. Okay, and geometry, now I change it to 50 to test it, and node combination you can generate. Okay, internal force, now we just to keep about internal force. You see here the actual load is similar with the previous column, is 310 pounds. The previous column is 370 pounds. Okay, now calculate. Calculation. Okay, this section is 83 for the top and 79% at the bottom. Okay, this section is passed when you use 0.5 multiplied with 0.6. Okay, and for the diameter you can double click to check it. Is 20. You have 20, and this diameter also use 20. Okay, after you can design and you can optimize it again and again. Now just to come back, now I want to keep it 0.4. Can check it again, it passed or not. 0.4. okay, and calculate it again. You see here the result, the element is not calculated, the stress is over, so you have to increase the section. 0.8250. okay, and calculate. You see the result is 83. Now we come back to analysis. And we close and apply the section to our model. Okay, this section will be updated to the column in the GAD. Now see here, this section auto update automatically to 60 multiplied with 50, and the old section is 40 multiplied with 60, and you can check for the section. See here, the section. And you have to check about the section is correct or not. Okay, it's correct. This section just update, and the other one is this section. See here, also update automatically. Okay. Now after you complete design for the beam, for the column, now you have continue to design for the beam. Okay, now let's start view in wireframe. And you select the critical beam. This one is the critical beam. You can click on it, and it's open in design module. Okay, you see here, this is the dimension of the column, because the column you not yet update. After you design, you have to update this section to 0.5. Okay, now let's start to geometry. Now the width of the support is 50. Okay, you can apply. You see here is 50 at the right, and at the left also 50. Okay, 50, and the section is 30 multiplied with 70 centimeter. Now you can check for the section cut. Opening, no opening. Okay, click OK. And for the diameter, we want to use for the 20 and 25. And for the length, we use 8. Okay. Load combination. This beam you can design it to receive for the gravity load, and for the lateral load include wind load. If you design for the vertical load only, you can did it for the horizontal load. But in this system, you have to design it both for the gravity load and lateral load, because your beam also receives wind load, to connect each other from one column to other column to make a system prime moment connection each other. Okay, to make your structure stable, so your beam also receive and design for the lateral force. And load definition, you can check about load definition. Internal force before automatically import from GED. Okay, you see here. And combination, you can generate and click OK. And you can check for design. Okay, the combination include all. Okay, now click on calculate. You see here, this is the reinforcement in beam. Okay, you 8 dB. You can check for the interaction drawing. You okay, number of diameter E2, E1, you can check in the body. 1 and 2 is 16. You 16 dB 16, so you can check it again about the reinforcement. No 16, apply and OK, and calculate it again. And you can click on this bar direct. Now okay, the diameter is 20, is correct, and at the bottom, at the first layer is 20, is correct. Okay, and at the top, okay, we use 2 rebar layer. Each one is 1 layer, is the first layer at the top, and this one is extra rebar layer at the top. Okay, you see here. Okay, you can check also 820. Okay, they were 20, So at the top you 8 dB20, and at the bottom you also 8 dB20 at the critical beam. Okay, I call it critical beam. Okay, you can check for the drawing and check for the siltation for the concrete. Okay, you can check here this one for envelope, ULS, bending moment, axial. You can check for the torsion, and for the moment axial you can check everything here. Bending resistance you see here, and the reinforcement, the longitudinal reinforcement, this red diagram is for the upper limit, this one for the lower limit. The limit for the design reinforcement is this value. Okay, the require. Okay, the require. So you input your it is the design curve or the longitudinal is your input. This one your input bar is less than the require, so your diagram will be out of this limit. Okay, out of this red diagram, so it means in the path. So in this one it path. You see here in this section it's nearly the limit, so it pass. Okay, for the transversal, for the shear reinforcement it pass. Okay, you can check and check for the deflection. You see here the deflection, simplified method, ratio D is around here, the limit is around here, so the design for the elastic deflection it pass. Okay, it pass. You can check for the stress. Here is the compression stress, is the compression stress of the concrete, and this is the limit of the concrete design stress is 25 megapascal, and this one 25 it pass. The limit for the reinforced tensile stress 320 when you divide the 400 megapascal of rebar with the safety factor, and the correct width also pass. You see when you analyze here, there are lots of errors during analysis about crack section, crack in the beam, or crack in the slab. So when you design, you can check here the crack width is passed when you include the rebar. Fire resistance, you can check the fire resistance, support reaction. Okay, now come back to analysis, and we can update. Okay, or you can close. Now I'm going to update. Okay, now we complete design for the column and for the beam. Now take a look for the wall. Okay, now you can check it for the wall. Now I want to close all. I show it only for the wall as there. Okay, now start from the slab first before we continue. Now let's start for the slab. Check. Now click on one slab. I want to show only this slab. Okay, after you select slab, go to result. You can check, sorry, for the moment about 8 axis. Okay, the moment about y axis. Okay, you can check here. Now you can show the rebar in the bottom in each direction. B direction. Now at the top. See here, the slab you the minimum rebar reinforcement, and it some extra bar at the column. So when you the secondary beam and you the main beam and the slab thickness is 13 centimeter. So the design require remain for the rebar is very low. Also you can check and design with module. Okay, now see here in the design module you can check for the design setting, slab, then for concrete. Okay, is correct. Cover and the thickness of slab is 13 centimeter. Come back geometry. Now come back to design. Okay, slab, then for concrete. Okay, then for concrete cover is correct. Now you can design setting, reinforcement diameter, in combination. Okay, we had to calculate And now you have to check about the error. You see here when the import this slab not include the beam, okay, the beam in the direction. So you see here an error, not include the beam in the direction also. The beam, we have a parameter beam here and here, here and here, and we had the secondary beam in the direction. So when you import in the module, it not include for the beam. Now let's check in the model again. So in this case, you can fix error by using the result from GAD directly. Okay. Now I have to press C and hold Tom and check. You see here, it's not import the beam and the main beam with the secondary beam. So the main beam import for this panel, but this pan not import. So will be error cannot calculate it according to the condition. So you have to use the result directly from the GAD. Now I come back to analysis. This one I don't want to update, I just close it. Okay. Now you can try again by open beam. Okay, click on beam. Okay. Okay. Maybe it can detect when you show beam. Okay. Now try again. It is still not can design with the condition. You have to use the result directly from the Graitec advanced design. Okay, now the result still not available because it's error during import the element to calculate. Now I don't want to focus on this slab again, slab anymore. Release this slab and continue for the wall. Okay. Turn off slab and turn on wall. Okay. Okay, now we show the result in wall and clicking this wall, you can show the result directly in GAD, but in this case I want to export to advanced design to analyze and design it in this module. See here, you can click on wall. You see the strength, concrete strength, and the thickness is 30, and right click, open in the module. Okay. Now check for the geometry is correct or not. Okay, the wall thickness is 0.3 meter, is correct. No opening. Okay, now start with the reinforcement. We want to use this reinforcement. Available or not, you can try and test it. And accommodation. you can generate the second. Click OK. Click on load combination, load definition, no. Load combination. Now we generate for combination and design, load definition. You see here, it automatically import from the Graitec. Okay, so we don't want to correct it. Now let's calculate. See here, this is for the wall, and you can check for interaction drawing. Okay. Okay, now you one is diameter of 12. Okay, now come back to analysis, close. Okay, now you can check for the core wall. The core wall we not yet apply the opening, so in reality we have opening to access into the core wall. Now we just modeling, not include opening yet. Okay, you have to include opening into design to check it again. Now I want to check the wall by clicking this panel again and open with design module. Again, design setting. Okay, wall reinforcement. Now we want to use only the available rebar. Okay, combination again, generate. Click OK. Then load. We don't want to change, we just to check it. Okay, okay, you can calculate. Okay, now you see here, you can check for the interaction drawing. one is okay 12 diameter. Okay, you can check here 12 diameter. Now come back to analysis. Close. We do not want to update. And now we complete design concrete wall, concrete beam, concrete column. We had to check another option in Graitec design now. Actually, you have to include P-data analysis. You have to active design for non-linear case and activate for the live P-data analysis. Okay, this is a very good option, but now I just show you how to design in the folder analysis. This is not complete when you have a high rise building and a long column, slender column. You have to activate the option to include for the non-linear analysis. This is very good concept for the high rise building. So now we have to continue to the manage document and generate report.